Okay, good morning, everyone. I'm Jason Cabral. I'm Chief Actuary for a company called MarkerStudy. So this is, my presentation is quite personal lines focused, but I used to work at Excel, and now Excel Catlin for about 10 years as an underwriter. So even though I'm an actuary, I have a lot of experience in sort of underwriting different risks based in Bermuda, London, and Singapore. So bit of a worldwide context on that as well. So today I'm going to be talking specifically about what we've done with machine learning, and we'll look at examples from other industries, because I think it's very important to look at, not just insurance, but actually how have other industries been disrupted by machine learning, and see what implications that could have for insurance. And I'll show you a specific proof of concept that we've done using machine learning. So first of all, to give you a bit of background on MarkerStudy, so I've been there for about 5 years. Started in the pricing space and then moved on to capital and reserving as well. MarkerStudy is a Gibraltar-based company. It's privately owned, and we've grown quite a lot in the last, especially in the last 5 years, through both organic growth and through acquisitions. So in 2010, we acquired Zenith Insurance, and about a year and a half ago, we acquired the personal line segment of Chaucer Syndicates, which we then rebranded as Zenith Mark. So now we're, for 2016, we were 730 million gross written premium, and that's mainly focused on, the majority of that is UK motor business. So we're a top 5 insurer for telematics in the UK. We also are one of the top 5 for pet insurance, so when I talk cats, it's dogs and cats, not catastrophes. And in terms of our investment in data and building a data-driven company, that's really helped us to achieve our goal of target loss ratio, giving us a combined ratio of about 95%, so 5% underwriting margin. So I wanted to take a step back and look at, where does machine learning fit in all this, and what is the evolution, and what's been the evolution of predictive modeling for insurance. So if you go back about 25, 30 years ago, to buy insurance or a motor policy, you'd either have to go on a high street broker or ring up a lot of insurers to get a quote. And the table structures were quite simple. You maybe had 15 rating factors. Some of it's okay, well, how old are you, how long have you been driving, etc., to build a price. And this was largely an underwriter-driven market where they look at simple one-way analysis. So one-way analysis is just saying one factor at a time. So, okay, what are your exposure by age, for instance, and what were the loss ratios to then tweak the pricing. And that was fine when the market was very simple, but then came in aggregators or price comparison sites into the market. And this was a big, this was a huge issue because of anti-selection. So if you got your price wrong, you basically got all the risks for that portion of the market, and you'd be underpriced. So this is when actuaries and statisticians came into the market and started implementing generalized linear models that Sandeep talked about. So that's the GLMs. And what this allowed you to do was to look at several factors at the same time to avoid sort of double loading, double discounting, and to look at places where, or factors that were very highly correlated. But then that wasn't enough for the market as well. So we wanted something where at point of quote, we can actually get all the information on an individual, and not just the information that they're telling you, because some of the information that they tell you on an aggregator site might be incorrect. They might change their data to try and get a lower premium. So this initially started in the U.S. with credit data. So what they found out was that if somebody had a poor credit score, it was actually very indicative if they were going to have an accident and claim on that for motor insurance. So now this is really, really developed, and UK market is probably one of the most advanced in the world. So when you go onto a price comparison site, I'm not sure if many of you know this or many of you drive, but we actually pull in information on where you live, make sure you have bank accounts linked to that address to try and prevent fraud, bring in your credit data, all the information on that vehicle, whether when you bought it, how many previous people owned the vehicle before that. Information if you had gaps in cover, pulling in industry databases from Q to see if you've had claims and convictions information before that you're telling us, and does that mismatch? So actually we have a very, very well-rounded picture now of what people are telling us. And we've developed a tool as well in real time where we can see people changing their information. So they started as an underwriter, and they changed to an actuary, then actually we can see that and make a decision whether we want to increase the price, whether we want to quote at all to try and prevent fraud. So that's sort of where the market is now and where we're moving to. So the recent Gyro conference, which is a conference of actuaries that was in Q4 last year, every pricing seminar was talking about machine learning. But actually it was more of a scaremongering, saying, are machines here to take actuaries or underwriters' jobs? And I don't think that's the case. I think it's very much a supplement for what we're doing now and a natural evolution in terms of the right tool for the right problem. At the moment, we only have sort of GLMs or looking at simple one-ways. So actually having another tool is just going to be another way for the actuaries and the underwriters to have more information. So looking at some other industries and what that might mean for insurance, hopefully most of you know this company, Netflix. If you don't know Netflix, it's basically a movie and series streaming site. So you get movies on demand when you want to watch them. So if you think of what industry this displays, if you remember a company called Blockbuster, basically if you wanted to watch a movie, a specific movie, you'd have to go into a physical bricks or mortar shop. It would be a very clunky customer experience because you'd have to kind of go through walls of DVDs or VHSs, and then the most popular films might have a bit more on the wall, so you kind of recognize it by that, new releases. But then if it's too popular, your favorite movie is not there. So a very bad customer experience. So Netflix said, well, actually, let's put the customer at the heart of what we're doing. And when they originally started out, they just said, well, let's just do a simple sending DVDs by the post. So somebody would sign up for a monthly membership, get as many DVDs as they wanted, and then Netflix would send them out, you'd mail them back. But then with the evolution of streaming, they said, well, actually, even that's a clunky experience to have to return a DVD, late charges, etc. So they came up with this automated streaming. But one of the real areas of differentiation, and where Netflix continues to put the customer at the heart of what they're doing, is around their prediction software. So if you see here what's circled, it says because you watched this movie or this type of series, you might like these other shows. So it's really showing how, and the way they do this is they look at what you're watching, when you're watching, some recommendations that you didn't choose, so what didn't you watch, and also just the popularity of videos. If lots of people are watching the same thing, then perhaps you'd like to see it as well. And why are we doing this? Why are we putting the customer at the heart of what we're doing? For Netflix, they say it's decreasing their customer churn, so going on to Amazon Prime or whatnot, by several percentage points. And this saves the company about $1 billion US a year. So sound familiar in terms of insurance, decreasing customer churn is what we're about as well, because acquisition costs for us as well are very high. Now another example from the medical industry, which I thought was quite amazing, is that a machine learning algorithm created by Carnegie Mellon was able to predict 80% of heart attacks on this cardiovascular ward 4 hours in advance of them occurring. So imagine what this could do to sort of that doctor's job or that nurse's job on that ward. So actually, instead of being reactive and having to react to a heart attack occurring and machines beeping, they actually know prior to the event and can prepare themselves, can actually prevent the heart attack from happening in the first place. And the previous manual system only did about 30%, or recognized 30% of the heart attacks before that occurred. And basically, this is a game changer for doctors. And if you think about it, that's not replacing the doctor or the medical staff. That's just giving them another tool to help them care better for the customer, in this case, the patient. Similarly, machine learning is going to be another tool for actuaries and statisticians. You will have pricing staff already looking at giving you indications of what they believe is the best price. This is just giving you another tool. And it's all about the right tool to solve the right problem. One thing when doing some research on this, one thing I found quite shocking was that many American judges are given risk assessments that are generated by machine learning that basically give you the likelihood that a person will commit another crime. So this is used in bail, parole, and sentencing. So if you think about it, it's feeding in information on this criminal or person being sentenced, and basically saying, well, what's the likelihood that, given this information, you'll go on to commit another crime, and then giving that to the judge. So this is all real, and why does the American justice system use this? It's because if you just looked at, so if you look at the table on the left, or the graph on the left, if the judge just chooses the person to be released on bail, almost 20% of those go on to reoffend. But if you got rid of the judge entirely and just looked at what the algorithm would tell you, only 15% would go on to reoffend. So it's actually reducing the reoffending by 20%. But I think this throws in quite a big ethical dilemma, because if you were there being sentenced and your sentence was either going to be 3 months or 3 years, would you want there to be no human interaction, and for an algorithm just to say, based on your information or your background, how likely you are to be reoffending? And what sort of information goes into building the models? Sandeep and Henry talked about sort of garbage in, garbage out. So maybe it's really predictive, but if you're using things like areas where somebody lives, or gender or race or whatever within the model, then actually this could be really, really dangerous and actually disadvantage several minorities. Similarly in insurance, we're always sort of segregating the model as well. So we have to be careful of what we feed into the model so that you don't get these adverse sort of outcomes. I mean, if you think of some things we use now around credit score, basically what that's saying is that richer, more affluent people with a better credit score pay less for insurance. So is that morally acceptable? In terms of applications then specifically to insurance, so some things that we've done in terms of the data enrichment I talked about. So when we got information from Experian around credit score and credit information, CCJs, etc., we had about 1,000 factors to test. So that took us 3 months to go through manually and test all these factors and which ones are important and how can we use that. So using the machine learning tool, that took us about 3 hours. So rather than 3 months, 3 hours. So definitely much more efficient. What I see that machine learning gives us over and above the traditional generalized linear models is looking at complex multi-way interactions. So what that means is looking at a lot of factors at the same time that you wouldn't be able to put into a model typically. What can we use this on? If you think about Amazon's model or Netflix, because you bought this, you might like this. We could use something similar for insurance. Because you bought this insurance product, you have this background. You might like to purchase these add-ons, or you might like to purchase a different type of insurance product that would give you more value for your money, basically. Other areas that aren't really looked at is around claims analytics. So claims is almost a dark art, if anybody's claims that pricing people don't really want to look at. But actually, around sort of claims information and fraud information, there's a huge wealth of data there that's not really tapped into. So I think we can look at how can we improve sort of the claims journey as well for individuals using machine learning techniques. And around fraud prevention. So fraud is looking at, all right, who's a typical customer and what do they do? But then what are the outliers? And actually, if we can pick out those outliers, pull them out and have a different journey for them, investigate more information to make sure that their claim is actually valid. So that's some ideas of what we could do, but what have we actually done? So we did a proof of concept and teamed up with a company called Data Robot, who provided some of this software, and I'll go into explain how this works in a second. And one of the aggregator sites called Money Supermarket. So what Money Supermarket gave us was basically all the information for a month's worth of quotes on their site. So they gave us information that people actually entered around their age, occupation, postcode, all the different factors that somebody would enter in their site. And then the factor that we were trying to predict was the average of the top 5 quotes. So they give that as well. So all the information and also what was the actual market price for this individual. So the reason why we might want to predict what the market price is to actually know, well, actually if we're charging too little for our, if we're being picked out and charging too little for that individual, could we maybe flex the price? So if the market price was 500, we were charging 400. Can we maybe charge 450 and still get away with onboarding that risk? So that's what we wanted to predict. We basically fed all that information for a month's worth of quotes, and then the basic way that the machine learning algorithm or this technique for Data Robot works is a bit like a football knockout competition. I like to think of it. So all these little dots here are teams, and the teams that represent sort of their algorithms. So the algorithms Sandeep was talking about. So you get them open source from competitions like Cabral and things. So it's we don't have to do any of this. So not doing any algorithm at all. Basically, DataRobot has a team of people going out sourcing the algorithms, and they put them all there. So then you feed in the data, and then basically say, okay, for these 100 top performing algorithms, test it on a small portion of the data. Using that portion of the data, which was the month worth of quotes, it only produces the top 50, so it reduces it down by half. So these are the best algorithms that perform based on this data, so you can roll a whole lot out. And then you just repeat that process. So you repeat it again, knock out a bunch more teams, repeat it again, so actually you're left with only the top performing algorithms. So actually knowing nothing about statistics, you can basically feed the data and saying, well, how does that work? How well can it actually predict this? So in this proof of concept, we put the machine learning algorithm against our GLM that we took basically 2 months to build. So 2 months to build that, 2 days to do the machine learning DataRobot bit, and what were the results? So what this graph is showing, on the next 2 weeks of quotes, actual quotes from Money Supermarket, saying, well, how well will your GLM predict the average of the top 5 quotes, and also how well will the machine learning algorithm you've selected predict? So if it's at 0, where the dotted line is, basically that means that it got the answer exactly right. So given that information, the model predicted the exact right price. If it's to the left of the dotted line, that means it was under-predicting, so the price was 500 and it was predicting 450 potentially. If it's to the right, then it's over-predicting. So you can see that using very little human interaction, actually the machine learning algorithm, which is the blue curve, was a lot higher, so it was better at predicting. So it got the answer right more of the time, and actually than our traditional GLM, which basically means it was a success. So some of the advantages for the machine learning technique that we looked at was that it was quite easy to use. The results were pretty accurate and unbiased. And then if you got new information in, you could refresh the model and produce an output, get the output. In terms of the disadvantages, it's quite a black box technique. We didn't need that much intervention. So could you just go out to market with this price? Potentially not. If somebody rang up and said, why are you charging me 500 quid more, and I just moved down the street and said, oh, computer told me this is the price. We have no idea what it's coming up with. Potentially, wouldn't be the best customer interaction there. It's difficult to understand and interpret. So if you were just presenting this to an underwriter, they would say, well, how do I use this, or what does this mean for me? And then it's quite a specific skill set needed to run, maintain, and improve these algorithms. So it's a bit, this data scientist is a combination of a statistician, somebody who knows information about about insurance, basically, but also people that know information about the statistical techniques. So you need some sort of specialist skill set if you want to implement this. But wait, there's more. I think, so can we just use machine learning to actually supplement GLMs, or actually is there another step? So this is what we're currently working on now, and we'll hope to have a product live on this in the next 6 months. So what this is a fully rated product using only machine learning. So if you think about insurance, we have an estimate of what the market price would be, and also we have lots of historical data around claims information. So it's not too much of a step to think, well, actually, let's try and predict what the claims, what our claims cost would be, add on expenses and whatnot, and then use the market price as well to basically maximize the difference between the two. So actually, you can basically write to whatever loss ratio you want with the most prediction, and the only other variable there is volume. So if you want to write to a higher loss ratio, or if you want to write to more volume, you have to accept a higher loss ratio. So you write to whatever loss ratio threshold you want, basically. So in summary, what have I told you this morning? I've showed that machine learning is disrupting other industries. So we've seen in the medical industry and also in movie watching that it is disrupting other industries. I think insurance is one of the next ones in the pipeline. Through the proof of concept, we showed that machine learning can improve the accuracy in predictive modeling, so it is an improvement over our GLMs, we found that. I like this old adage, if the only tool you have is a hammer, you tend to see every problem as a nail. So I think the proverbial hammer here has been the GLM, so everyone's trying to shoehorn information through a GLM, when actually that might not be the best tool for the problem. Do we need to go out and hire lots of data scientists and attract them away from Google and Facebook? I think probably not. Actuaries and statisticians are already well placed and are actually quite keen on learning these techniques, and they have the insurance knowledge. So they're quite well placed to actually exploit some of this. How do we get to do this proof of concept? How do we get in the data robot and everything? You really need board level buy-in. So you need to have somebody there to say, all right, we're not just investing in old technology, but actually let's invest in some of these new techniques. In terms of ethics, when you create a segment of one, there's winners and losers. So will this create, as we get more and more specific, as we add more and more data, as we segment more and more, specific individuals that are uninsurable risks for the whole market, potentially. And finally, machine learning is a black box. But if you go back to the medical example, do the doctors need to know how the machine learning algorithm is working to actually use its output, to actually save lives? Most of us have smartphones. We might not know every way of how it works, but actually we know how to use it for the output. So I argue that actually not knowing every single way of how the model's built, and most of us are implementing models every day that we don't necessarily know exactly how they're built. So I don't think that that's going to be a major problem in the future. And finally, I'll leave you with this quote from a recent article from The Economist that I thought on machine learning that I thought was quite relevant. For industries that embrace machine learning, the future will depend on how well they marry its predictive power with old-fashioned human wisdom. So with all of this, it's another tool, but don't forget your common sense.